this is to be presented by the spelling of guns. The spelling is more like Polish to me, so I was a bit difficult pronouncing. So let's welcome Mr. Gans to the clap of hands.
Thank you and welcome to the presentation. If it's acceptable, I will speak without microphone because I feel young enough to do that.
Thank you.
Putzmeister Solid Pumps. Putzmeister is a company which was founded not so old like GhIE. It's a very young company. It's founded in 1957. At that time I was 3 years old. So I was not the founder. And my name is Rudolf Gensel. The operations of Putzmeister, you find it worldwide. It is in Eichtal, close to Stuttgart, an industrial area together with Mercedes, Porsche, Ritz and of course Putzmeister. All the green spots you see on the global map are operations with manufacturing. Let's start from the Far East. It is Shanghai, it is India. We have in Turkey, Madrid, USA operations. The blue spots you see, that's another division concerned with water. Here I show you some aerial pictures, which is the headquarter, the special place where the welding and beam construction is done. Then South Africa, I have forgotten before, but we have an operation, you see the picture. America, India, China. On this graph you see that Putzmeister was really hit by the economic crisis. I show here only the 2008 because the 2009 was even lower than that. Nevertheless, we still hold about 3,300 people worldwide trying to serve the customer. The range of the products and activities is concrete pumps built on a truck like Mercedes or MAN, which are the most selling trucks, or you have a belt which you can also put it on the truck, bring it to site and supply the things. We have rigid installed booms. Okay. Right. Pumped up. Even to the Burj Dubai, in a height of more than 600 meters, it is pumped. The center of the business of Putzmeister is here. It is coming from the silo, going to a pre-compactor and mixer, to the pump and then into a pipe. Organization. Putzmeister is in a holding organization with the columns of concrete technology, mortar technology, pipe technology and industrial pumps. And underneath there is the Putzmeister solid pumps. Our markets and applications. It is offshore, it is biomass, it is dredging. Biomass, maybe we have a subject over here. Offshore, maybe more in Nigeria. Sewage treatment plants, waste recycling, cement industry. Power station, mining and miscellaneous. You will see during the presentation, we will have about 30% of our turnover in the next 5 years in applications which we don't know yet. We are really at the start and looking forward to a very successful future. Now, after you have all had your lunch, we can see and show you a little bit of the things we are pumping. It's not looking nicely, but you have to get rid of it, and our concept is transported within a pipe. Within a pipe, it does not change the chemical, it does not react with the air, the wind does not harm it, it does not blow away. So it is sealed in a pipe and it reaches its destination where you wanted it. And as I said before, we are at the beginning, so we try really to pushing the limits of pumping. But pumping, we are not using really centrifugal pumps, we are using piston pumps. And I show you an animation where you can see, hopefully you see soon, yes, how media is pumped with a solid content of 20% only. Here you see organic waste. We have organic and inorganic. Mainly in Ghana, I believe we will concentrate and focus on the unorganic waste, where we can reach a solid content up to 85% dry solid content. Slurry, paste, cake. These are the names of the things we try to pump. And you see here the limits of centrifugal pumps, because here the shear stress is brought over the percentage of solids. In other words, up to the end of the turbulent flow, you can go with centrifugal pumps. Here we have an overlap, so we don't really have competition with centrifugal pumps. It's a different media, it's a different application. And we go up to cake. We cannot do each and everything, but we can do a lot. And you can see here a very, very wide range. Even over the liquid limit we can go. If you cluster it, tunnel application, mining application and industrial application. In industrial you have paste transport, you have earth transport, you have ash, you have coal, and you have dredging, which is the normal soil. In mining you have tailings, you have backfilling, mud, injection, shotcrete, coal transport, mineral transport, ash transport. And in tunnels, I don't know if you are building tunnels in Ghana, who knows this? No tunnels? Okay, so forget about this section. Space for depositing. If you pump this, you usually, with centrifugal pumps, you use water to transmit the debris and the soil. That means you first have to move the water and you have to get rid of the water. With this type of pump, you use the water just as a liquid, as a lubricant. So the amount of water is very reduced, so the energy consumption for that is much lower because you don't have to touch it. On the other side, you don't have to spend too much water, which is a valuable resource. Now you go and see here the first picture where the slurry is brought out in a big place, and if it's thin, you have 1% of inclination. If it's thicker, up to 7%, and we have a low slump test where you can measure it. If you go a little closer to that pictures, you can see that like here, and you see here the picture. You put it full slurry, then you take this away, and what it relieves here, you measure how much the level is dropped. So if it's a 7-inch slump, that's already nice, and no centrifugal pump can take it, and I hope Mr. Yanoda is not very mad at me on that point. You can hold the paste just as a hill. You can put it behind the wall, or you make it just downhill and making a dam to keep it where you wanted to have it disposed. Now I go into the dredging. Dredging is bringing just from a loader to a mixer, into the pump, and you bring it wherever you wanted it. You don't touch, you don't drive down, you don't waste energy for the truck, and even you don't have to pay for the truck driver, never mind. Land reclamation, desludging of contaminated sites. We have disposed a tar lake, which nobody wanted to touch it. So by machines it is put into the pumps and then brought where they want to have it. Nobody touched it by hand. Here we have an example in Japan, where the biggest dredging pump from Putzmeister solid pumps is installed. You see it here on this GhIE, and the whole airport is filled up with the pumps of Putzmeister as land reclamation. Later on you see the S-tube, and I have to come back because the weight is very important to tell you what these pumps are robust and endurable. Another dredging, this is the site I just mentioned. And here you see a twin pipe. Even on a lake, you can leave it on a swimming pipe and bring it, let's say, if it would be a dam, you can bring it and make it a green around it, using the soil and recycle it. Now I go underground. We have mines in Ghana, up to which depths? Eric, you know that? Anybody else knows that?
1.5
Okay, so comparable with Germany with the coal mining, yes. Good. So within there, you can get the water out, you can get the mud out, you can backfill. In most cases, it is used by blowers to backfill. But here, even in China, these pumps are used to backfill. Because if you have a mine with about 800 meters or 400 meters, stay with 400 meters, you have two shafts. And with a big shaft, the earth, after you have finished the exploration, will go down, maybe by 50 centimeters. And if your groundwater is at minus 20 centimeters, later on you can plant rice at that place. So it's in some cases not recommended to leave it go down. And as well, it goes together with the ventilation, the GhIE ventilation. You can easily use it and build the walls where you want it. And you don't have to use machines because you just bring the pipe where you wanted it, you pump it, leave it going down. Even we have thought about assisting the Americans with the BP to close that hole by concrete pumps, but they already failed with the mud, so concrete cannot come there. Backfilling, I mentioned it. Here as well, I run a little bit competition to centrifugal pumps, which normally are used in the mines. You can see here 25 centrifugal pumps, which are dewatering this mine shaft, and here 2 pumps going in a sequence, because these pumps go up to 1,500 meters with a lot of, much less material used to create the pressure. Backfilling. Here you see a typical longwall. I don't know if you are mining with a longwall here in Ghana, but that's the type which is used in Germany to bring up the coal. And this is the underground installation. Now I jump a little bit to our continent here. In Tanzania we have Bulyanhulu, a project where paste is pumped. That's the total installation. It is paste backfill. The cost is reduced by 40% compared with the high density slurry backfilling, which they had before. And this is now running for, I think, 15 years. We once in a while selling a rear part, but no spare part, because it's rather robust from the first day. and the customer is happy with it. And with the pump, they bring it to this hill, and on the top of here, the slurry comes out, and it goes there to lay there, to settle. Again, the slump test. Here we have a triplex pump. If people here are from the water section, you have water hammering. Anybody here from water hammering? No? Okay, good. If you shut off the pump, you have water hammer. And with a piston pump, it is very likely because you push and stop, and then the other pump pushes and stops to create fluctuations. And then if you control the three of these pumps together, you can reach a pulsation-free pressure. You can see here, this is the pressure, then this is backdrawing, so it is filled from here and here, and then comes the next stop. So by this, you easily reach a pulsation-free operation. If you have two pistons, you can reach this as well. Then you use a PCF valve, which is doing almost a similar, and the graph is shown here. You have a long suction, a pre-compression, and after the pre-compression has reached the pressure which you have it in your pipe, then the valve opens and the delivery starts to continue. Offshore, drill cuttings. Drill cuttings, they come to shore, and in all the European waters, it is zero emission allowed. It is not allowed to leave anything on the sea ground, so you have to use it and you have to get rid of it. That means you get it on the platform, you take it out of a shaker, and the mud goes into a pump. The pump supplies to a supply vessel, and from the supply vessel you bring it to shore, where you dispose it at the place it belongs to. These are ships, typically. For this shape is Ulstein. Ulstein is the only shipbuilder building this type of ships. They are not using the conventional nose, which you have normally under the sea. They are using this, and they are very happy with it, and both of these ships are installed with the KOS 4080 and a 200 kilowatt power pack. Okay, thank you. With Putzmeister pumps you can also win awards. Shell in Netherlands won an environmental award with our pumps. We have replaced another piston pump manufacturer, which I don't want to call the name, because it is just a fact. We have done the job. We have challenged the Shell standards, the health and safety requirements, the ATEX, and we have used super duplex material. Here you see an injection of water or whatever you can make it to reduce the friction losses of a slurry and the sludge. You put water or any other media on the circumference of the pipe, and then you transport the things. That's a patent we have together with GhIE in Galex, French company. And this is the system from the container, the pre-compactor, the concrete pump here, and then to a way using the reservoir water pre-pressurized to get rid of this as well. Now I have told you a lot about applications which we can do. If you see the invitation in the newspaper, we have touched just 3 of these applications, which I imagine could be good for Ghana and for you as the engineers who has to design the future. The products. we are using SHP. It's a seat pump with valves which are hydraulically operated, the KOS with the S tube, the KOV, which is controlled by valves and balls, and the EKO, which is single piston pump, which is used to unpack overstored food waste and keep it there to go and make it digestible for bacteria and create biogas, and from the biogas you make electricity. KOS, you use it for very rough and thick media. Up to 80% of the piston diameter you can put stones and pump it. It is really unbelievable. You have to see that. HSP is more for the fine grain sludge, for the longer pipe, for the better control. And I have here hopefully an animation so you can see how such a piston pump is working. Before I start the animation, here is a pre-compactor, 2 screws which they are rotating, feeding into the hopper, and then it goes into the pipe and throughout the S-tube into the pipeline. I hope everybody can see the animation. Okay. You see, the feed is coming from here, falling down here, being pumped in, pressed out when the S-tube is at its position. And now I try to invite you to take a ride through the pump. I hope nobody will get dizzy. Now you see the S-tube. Now we are in the cylinder. The piston from the other side you see. And now you as a media are pushed out through the S-tube into the pipe. The stroke length of these pumps from here to here is 1 to 2.5 meters. The diameter of the piston is from 120 millimeters to 560 millimeters. The pressure, we go up to 150 bar, which is 15 megapascal. So I really enjoy taking the bar, because the bar has a nice other word with me, which I like it. 500 meters cube. And we have piston pumps which they are in operation 130,000 hours trouble-free. Now we are here with a hydraulic operated valve with the same dimensions. And you can see here from this animation how the valves are working. You can compare it basically with a car. The only thing what we have missed here is the spark plug. I have here a summary of the basic pump types for ash handling, which is the KOS 2180. You see here the confirmation about the capacities and the maximum pressure of 150 bar. In water column it is 1,500 meters. And here you see the feeding devices. It's all engineered and manufactured by Putzmeister solid pumps. Now you can see you can feed from below, you can feed from up. The main thing, you have to have a reasonable filling rate of this piston. As well, here I got an animation showing how it is fed, and you can control it by this red ball where it is going, and it is safely reaching the outside of the piston pump. Here is the ball going in, and the S-tube supplying it to the outside. You need to store these things so you have a continuous flow towards the pump. This is done by silos and pre-compacting, where you need as well hydraulic drives to get it out of the silo if you have a flat basic bottom into the pre-compactor screws into the pump. Basically, you can say from the silo up to the injection nozzles for coal slurry, we are doing a whole system. So we are not really eager to sell pumps alone, because it doesn't work. You need a lot of know-how how to use it in order to get the system run well. But when it's running to the satisfaction. Here you see these sliding frames into rectangular silos and circular round silos. We have here a picture. Unfortunately, I don't have a man standing beside that one, but if I would stand, I could just look into that pipe. This pump has 150 meter cube, it's 60 bar, and the hydraulic set to drive that pump has 2 times 500, that means 1 megawatt motor power. This is just one of 5 pumps which we have delivered and supplied to India just the end of last year. It is commissioned, it is working. Putzmeister solid pumps has its own test stand. Up to 1.6 kilowatt we can test whatever pump we have, even 60 cycles if it's wanted. And here are the first customers from Mexico, which they have the works test in October last year. Development. We are doing development ourselves. We are improving the hoppers and the pipe connections, monitoring the SPH valves, reducing the friction loads to be efficient and well controlled. So it is all in our hands. So I can make a stop now before I continue a little bit further. Where are the questions? How can I help you? Maybe we use the microphone for a... Hello?